Hi everyone, we are going to do one more set of guided R and S solving together. We're going to start with chiral carbon 1. Here is our chiral carbon. The direct atoms attached to this chiral carbon are nitrogen, carbon, carbon, and hydrogen. Hydrogen is the lowest priority. Nitrogen beats the carbons. It is 1 priority. Now that these carbons are tying an atomic number, we say what are they bonded to within 1 bond and what are their atomic numbers. We have hydrogen, hydrogen, oxygen for that carbon on the right. We then have hydrogen, hydrogen, oxygen over here, and what we see is that those tie. Therefore, we have to go 1 further, okay? And those are both oxygens, so those tie. So we say, what are they bonded to? And what they are bonded to within 1 bond is carbon and carbon, okay? Notice I said just carbon. Therefore, those tie. And what we are going to do is go 1 further and say now our reference points are these carbons. Here, this carbon on the left is bonded to oxygen, oxygen, and carbon. Remember, we give double bonds, single bond equivalences, treating that carbon as being bonded to 2 oxygens. This one on the right side is bonded to hydrogen, carbon, and carbon. Okay, oxygen beats carbon. Therefore, this is 2, and that side is 3. We have 1, 2, 3. This looks like it's the R configuration. However, the lowest priority group is on the solid wedge, so we flip what we see, and the correct configuration for chiral carbon 1 is the S configuration. Okay, so this is a funky example about having to go far around, right, looking for a point of difference. It's okay to work your way around, but you have to be meticulous about it. We're now going to solve for the configuration of chiral carbon number 2. Here's chiral carbon number 2. The direct atoms attached are carbon, carbon, oxygen, and then we have our implicit hydrogen on the solid wedge. Oxygen is 1, hydrogen is 4. Because the carbons have tied in number, we say, now these are our reference points, and what are they bonded to? This left carbon has hydrogen, hydrogen, and nitrogen. Hydrogen, hydrogen, nitrogen as the atomic connections. Here we have hydrogen, hydrogen, and carbon. And carbon loses to nitrogen. Therefore, we have 2, and our third priority being there. 1, 2, 3. This looks like it's S, but because the lowest priority is on the solid, we are going to flip what we see, and it is truly the R configuration. Okay. Now, again, be meticulous with going 1 bond at a time. That's what it takes to solve R and S accurately, is assigning priority accurately. We have now our final asymmetric center that we will do together. Here's the asymmetric center. The initial atoms connected are bromine, hydrogen, carbon, and carbon. Bromine is higher atomic number than carbons. Hydrogen loses to the carbons as the 4th priority. Now, the carbons, because they tie, those become our reference points visually. We have hydrogen, hydrogen, carbon, H, H, carbon. And on this side you have H, H, and carbon, so those tie. We then have to move to the next carbon and say what are they bonded to within 1 bond. H, H, carbon, H, H, carbon, those tied. So now we'll go 1 further, let's make this in purple now, and we have just H, H, H versus H, carbon, oxygen. This side will win, higher priority, so we have 2 and priority 3. Okay, this is a little messy. Let's clean that up a little bit before we go any further. Because remember, when the lowest priority is on an in the plane of the page bond, what you will do is take what is the lowest priority, 4, and you're going to put it in the back, and you're going to switch it with the priority group there, which here happens to be 3. You will then make your semicircle from 1 to 2 to 3. This looks like it's R, but because we interchange 2 groups, the true configuration is S. Okay, I'm going to do that one more time for you. So remember, if the lowest priority is on an in the plane of the page bond, you will take it and put it in the back and switch it with whatever is in the back. After the interchange process, you will do your semicircle from 1 to 2 to 3. This looks like it's R, but you will flip it to get the true configuration of that asymmetric center.